Hello, everybody, and welcome to our webinar today of PVsyst. My name is Bruno Wittme. With me is Oriane Canes, and later on there will be Michele Oliosi also joining us to present you the novelties on PVsyst 8.1 that was released a month ago, and also on the other products that we have been developing and which are new PVsystBasic and the novelties of PVsyst CLI. So the outline of the webinar will be organized in 4 parts. We will start by presenting a little bit the novelties of the PVsyst version 8.1, namely the weather data import wizard and how it improves the importing of weather data, and the sub-hourly simulation, which is really the major improvement of version 8.1. Then we'll take a short time to briefly present a new product that we've been developing. It's called PVsystBasic, and it's a simplified simulation of solar pumping systems right now. You will see later how it works. And in the third part, we'll have a presentation of the novelties in PVsyst CLI, the command line interface of PVsyst, where we have introduced recently the possibility to create new sites automatically with a command line. Finally, at the end, we'll have a Q&A session, so where we'll try to answer your questions. The questions you have, you can insert into the Q&A tab that you will find on Zoom. Please write all questions in English. Questions which are not in English, we will simply refuse and ask you to reformulate them in English, because our team, which is behind the scenes and accompanying us, are doing a great job. Need to answer to all the questions. There's also a separate chat where participants can chat between them. So this you may use, but we will just moderate a little bit on that. There will not take questions which you write on that chat. So please, if you have questions, use a tab that is foreseen for that. Finally, I would like to remind you that this webinar is being recorded, and in a week or so we will publish it also on YouTube. And the questions that we'll not be able to answer today, if there are too many, we will nevertheless record them, write them down, give answers to them, and when the video of the webinar will be published, we'll publish also answers to all the questions that we didn't manage to answer today. So in case you are in the situation that you ask a question that we won't answer, you have to be patient and wait for the video. And with this, I start the part on PVsyst 8.1, so the latest PVsyst version that has been released, and where the major improvement was a sub-hourly simulation that we will show you later on. But before we do that, I will pass over to Oriane, who will show you how the new weather data import wizard works. Please, Oriane.
Thank you, Bruno. Hello, everyone. So let's get started. So our major update is sub-hourly simulations. And of course, if you need to run a sub-hourly simulation, you do need sub-hourly weather data. So currently in PVsyst 8.1, there are 2 main ways of getting sub-hourly data to run your simulations. The first option is the new updated Meteonorm DLL, Meteonorm 9.0, that allows you to generate synthetic data at the minute scale. And then the second option that you have available is our custom file import that has been completely reworked and now allows you to import any kind of data you wish from the minute scale to the hour scale. So I will share the PVsyst screen, and I will show you briefly how it's done. Maybe I will remove this presentation. Thank you. Thank you, Bruno. So let me just highlight my... Perfect. So we'll be looking at the database tab of PVsyst. And we'll start by using the new Meteonorm import. So the new Meteonorm import is available when you look at geographical sites here. And you'll first need to create a new site. This is the same interface as we used to have. So for any new site, you can choose a location on the map. You'll accept the selected points. And here, the main update is the weather data import. You now have the Metronome version 9.0. And here you can select to either import hourly data or minute data. So if I click on minutes and import the data, here in the background, you are already generating your MET file. And the results of the MET files will be also saved in the site as monthly weather values. So here you have the monthly values updated. And when I save my site, so that's the first stage for saving the site, it's saved. And after the site creation, I get also prompted about saving my new weather data. And yes, here I do want to save it. I'll keep the default name here. And that's already done. I have my file available, and I can look at it in the weather data tables and graphs here. Let me open it. Up is the right file, and if I look on graph here, you now have the sub-hourly option to display your data. And if I have a look at my radians, I can see that I have a nice little file for my simulation. So that is the first approach. Now the Meteonorm DLL is also available in the synthetic data generation tab here. So it's going to be the similar process behind the scene. You can select a site. The data here can come from any source you wish, and you'll generate the same data from the monthly values that are specified. Here is the choice between hour and minute option. So if you select minute here, you'll get a 1 minute data file. Now the second option is the import a custom file. This feature has been available in previous version, but the interface has been completely reworked and it looks very different, but the process and the concepts behind it is quite similar. So you need a CSV file as you have the source that you first select. And then in order to import your file, you need what we call a MEF file. That's a formatting file that will just tell PVsyst what data is to be found where. You can either create a new one or use an existing one. So here in this demonstration, I'll just use an existing MEF file. From this first window, you can already display your CSV file here. And I can already check if I have selected the right separator to read my file. If I choose the wrong one, you can see how it displays. Clearly, I need semicolons, so that was a correct choice. In the next step, I will then have to choose the site, the geographical site associated to the weather I want to import. It's a very important step for us to be able to compute the sun position correctly. Again, either create a new site or use an existing site in the database. I will look for the site corresponding to my data. Oops, sorry, I was typing at the wrong spot. Up, here you go. I get all the information displayed and I can move on to the next step. And here we arrive at the main window of really the MEF file itself. So again, I can display my source file next to it, and I will check all the parameters that I have defined here. So the most crucial parameter is probably the time step here. That has to match what is in your file. So here I can check in my minute column, I do have 5-minute data. So my time step is defined correctly. I have to define how many header line I want to skip. Then in the date tab, I'm going to define how the date is read. So here my dates are read on the file. There's a 1 column per month, day, hour, minute. That is all correct. I can check it here. I can then have finer settings. Is there daylight saving in my file? Do I use legal time, universal time, time shift? All of this is available on this window. Then on the next tab, I have my variable mapping. This is where I choose which variables I am going to import in my file. So here I'm importing irradiance, ambient temperature, wind, and humidity. And the PVsys variable you have chosen will appear on the top, so you can check that you have selected the right columns. So the file has already been converted in the background, but here, if I look at the message box, I do see that there's something wrong. I have a red message, many things were generated. So I should really check what's going on with my data, and I will open the weather table and graph window here. That's what I get. So here, don't panic, I only have 1 point because my file is 1 month of data only, so that's okay. But I do have a message telling me here that there's something wrong with my relative humidity. If I want to learn more, we now have a new tab called the generation log that will display every single message from fatal errors to infos that happened during the conversion process. And here it tells me there's something wrong with my humidity, that the range is weird, and I should check the unit. So I can go back to my window here and check what I've done. I imported the humidity as a ratio, but clearly the values are for percentage, so I will correct that. Change the ratio to percentage. And as soon as you change something, PVsyst will recalculate and re-import the data in the background. Now it looks much better. I have almost nothing in my generation log. I'm just told only that I have a few timestamps missing in my file, and that PVsyst has filled some of the missing values. If I want to check that, I can go even more in depth, for example, in my graphs, check my sub-hourly values. The missing data was indicated at the very end of my file, so I'll have a look at what's happening. And here, what you see is, unfortunately, 2 hours of irradiance data missing. So in this specific case, I have just truncated my file a bit too early, and I'm missing 2 hours of sunshine. If you ever get missing irradiance data in your imported data, it will be considered as 0, so just there will be no simulation at this hour. So let's say I'm happy with what I have obtained. I can close this window, go to next here. I'll be prompted to save first my MEF file, and yes, I want to save the correct unit. I'll write it. And finally, on this final window, I can just save the weather data that I have created. It already exists. I'll write it, and I'm done. So that's really it for the import and generation of sub-hourly weather data for now. In the future plans, we do need to improve this import to allow you to import multiple years of data at the same time. Right now, we still have the limit that we had in PVsyst 8.0. You can only import 1 year of data. Each MET file, is always composed of 1 year of data at maximum. And in the next step, we will also update the known format import. Right now, known format only works with hourly data, but in the next releases, we'll eventually switch to be able to also import sub-hourly data with the known format function. And I think that's the end of my part, Bruno, so I'll give you control again.
Thank you very much, Ariane, for this nice presentation. I will quickly close this and come back to our slides. So once we have created a sub-hourly weather file, and let me say that you can you can do a simulation now with that, and the simulation that you will run in PVsyst is based on the time steps that PVsyst will find in the weather file. And you have the possibility to create time steps down to 1 minute, but also larger time steps like 5 minutes. We've just seen an example of Oriane, 10 minutes, 15 minutes. I mean, it's your choice. And you see here on the bottom, the simulation results of hourly steps and 1 minute steps makes a big difference in the precision and the details you get out of your simulation. This is an example of generated PV power with clipping, and you see that the clipping is much better modeled if you have the minute detail than if you use hourly averages. So to be able to implement these sub-hourly or to make a reasonable sub-hourly simulation in PVsyst, we had to adapt some physical models. So it's not just simulating the same way in shortest time steps, but we had to make sure that also the physical models are adapted to these shorter time steps. And there were mainly three models that we needed to be adapted for good results. The first one is a decomposition of direct and diffuse irradiance that you need when you have weather data or import weather data that has only GHI, for example, or only POA irradiance. PVsyst needs to figure out which part is diffuse, which part is direct, and models are used for those. And they had to be adapted for the sub-hourly case. Then you have the transposition model that goes from the irradiance on the horizontal plane to the irradiance on the POA. These models also, that's the Perez model that's typically used by default in PVsyst. And these models also were developed and validated for hourly time steps. And when you do this, exactly the same thing with sub-hourly time steps, you get biases. So we needed also to adapt those models to avoid this bias in the sub-hourly simulations. And finally, there's a thermal model of the PV modules. If you make hourly simulations, you can admit that you can use an average temperature, a stationary temperature for the whole hour. But if you go down to the minute scale, you have to take into account the thermal inertia of your PV modules. And this was also put in. This is the example you see here on the right side of the slide. You see the difference between the steady state model, which basically follows instantaneously the irradiance, and a more sophisticated system model that has some thermal inertia built in. There are other things we need to adapt also, namely the importing of time series for simulation parameters. I remind you that if you have, for example, self-consumption, you can import load profiles, or now you can also import time series for the grid limitation, for soiling, power shifting, and so on. And of course, if you import these time series, you don't import them together with the weather data, so you can have a mismatch between the time steps of your time series and of your weather data, and the simulation needs to manage that. So all these were developments that were necessary to get a sub-hourly simulation. And I will show you now how the sub-hourly simulation looks like by just following up the example from Oriane and making a simulation with the weather data she generated. So I'm going here to project, creating a new grid-connected project. It's completely empty. I will choose a file. By default, PVsyst will present me the last generated site, which is the one that Oriane just did. So I say OK. And PVsyst identified this 5-minute weather data that was generated. This is 1 month in July that has been generated for this demonstration. We take only 1 month to make simulation time short enough for this webinar. So I save my project. This is my example for the webinar. And once I have saved that, I can create a variant. Now I have prepared a variant so that it doesn't take too much time, which has trackers on terrain. I will import that from the other project into this one. So here we have a system, a large system, which is on a terrain. These are horizontal axis trackers. And as you see now, PVsyst detects that we have 5-minute weather data here and proposes us 2 types of simulations, the hourly or the sub-hourly simulation. And the sub-hourly simulation will follow the time steps of the weather data. So I can just run the simulation now, and you will see that for 1 month, it's reasonably fast. Of course, if we make a simulation for the whole year or with minute time step data, this will be accordingly longer. But you see, we have the results here. And I can look at hourly graphs, for example, just looking at the results of the generated energy. And you see, I have now my results here in 5-minute steps and not anymore in hourly steps, which were much coarser. So this is one way to simulate, and for the situation where you have minute step data or you want to simulate a full year, Of course, this will take some time. If your weather data spans a full year, you might need to find more efficient ways to simulate your project. So we have foreseen this. As you've seen before, we have here the option to just switch to hourly simulation and run exactly the same project now in hourly steps. And you see that goes much, much faster. We have the hourly results. We can look at the report. And if you are interested in understanding where the sub-hourly simulation gets you more precision or gets a different result, we can compare the report of the two simulations right now. So I open the report, I compare it with my 5-minute data, and you will see that the two results are quite similar, and that it's mainly where the sub-hourly models needed to be adapted that we have a difference between the two results. So you see here on the left side the hourly results, on the right side simulation with 5 minutes. You see that there's the difference between the two in performance ratio and also in bifacial performance ratio does not differ too much, which means that the hour simulation for this example is quite good. If we go to a detailed comparison in our loss diagram, I will not run through all the differences, but I will just point out that the main differences between the two results come from the transposition, which is the very first value you see here, from the diffuse irradiance on the rear side, which is defined by the sub-hourly models that have been adapted, and finally the clipping losses of the inverter, which are quite high here because we have a big AC-DC ratio, a very large DC-AC ratio for this example. You will see that the differences are also mainly in this part of the clipping losses. I remind you that the hourly simulation of PVsyst already had the possibility to account for sub-hourly clipping losses in case you had sub-hourly weather data. So if you were importing sub-hourly weather data. And this has now is more automatic in our case because we simulated hourly steps with a sub-hourly weather file, and PVsyst automatically applied the model. And we see here that we have a gain or additional loss due to sub-hourly clipping of 0.88% on the left side. And if we compare the two values now of the detailed simulation, we see that this correction matches quite well. It's overestimating a little bit the losses. So of course the detailed 5-minute simulation is better and more reliable, but you see that even though you can run an hourly simulation or already get a very good approximation. And this brings me to my last point. I will just save this file hourly results. Brings me to my last point. So the sub-hourly simulations, of course, give you more precise results and a better simulation. But of course, it comes at the expense of a longer simulation time. And we try to cope with this first by giving you the option of quickly switching between hourly and sub-hourly. So in an early design stage, you can run just the hourly simulations, and then when you need the detail, when you make your final simulations, then you can easily switch to the sub-hourly simulation. And the other thing that is useful to remember in these cases is for in the advanced simulation, you have the possibility to make a simulation over a reduced time span. So here we didn't need to do that because it's only 1 month. But if you have a full year of minute data, you can, for example, choose to run only over the summer months where you have, for example, clipping to understand the clipping and the details of the clipping. And then, of course, your turnover of simulation and analyzing will be much more efficient than if you run always the full year. Okay, and with this, I will close this part of the presentation, come back to our slides, and this is the end of our first part of PVsyst 8.1. Thank you very much, Orion. In the second part, we will will present you very quickly a new product that we have developed, which is called PVsystBasic. It's in principle a simplified PVsyst simulation for small systems, and it's really aimed at rural areas which are far from the grid. And it's meant for to be able to make an easy system design and sizing for people which have also low level of training, limited training and simulation experience. So the original idea is really to help in regions or areas where people have difficulties with access to water and electricity, to give them means to reasonably design and size small PV systems and solar pumping systems that they can set up. Currently, PVsystBasic will only simulate pumping systems. You see a screenshot example on the right side, but on the long term, in the future version, we will also add standalone systems to this. The tool contains also a set of technical tools that help with the understanding of very basic electrical concepts. I will show you later on 1 or 2 examples of how this works. So let me show you then how PVsystBasic looks like. I will pull it over to our screen, minimize this. So as you see, it reminds a little bit of what you know from PVsyst, and that's no coincidence. The simulation engine that is behind PVsystBasic is the same as PVsyst. The only thing is that we stripped a lot the parameters that you can define, so there's much less level of detail that you can define. And we also simplified the way or the approach how you set up a simulation. And I will just open an example that comes with PVsyst CLI, which is a pumping system for a well. And in principle, for running a simulation with this tool, you have a linear workflow on the left side and the simulation or guidance of what introducing of parameters on the right side. This is a complete demo project, so you already have simulations results, but you can navigate back here to the different steps of setting up your system, or if you want to be quick, you can just click on this button. And you start by selecting weather data and the system type. Right now, you can pump from deep wells or tanks or from a lake or a river. In this example, we have a well. Then you define the water needs that you have. You have different levels of detail. Here we have 40 cubic meters per day, and you specify the reservoir that you want to fill up with your water, yeah, the dimensions. In the next step, you put the left side, and you notice that this image that basically represents the whole system that you're setting up has now passed the highlight from the water tower in the beginning to the borehole and the well here on the left side. And this helps just to focus on the parameters that are being entered in this step. So you have to give the details of your phreatic levels. Then you have to specify the pump. The pump comes from a component database, which is the same as the PVsyst database. So you have access to exactly the same components. And PVsyst chooses or marks the pumps which are adapted for the system and match to our previous choices. So I keep this choice. Then we have the same choice for the PV module. You see again, find everything that is in the PVsyst database, but you have limited way to define your strings of and modules in series and parallel. Finally, you set up the orientation. So there's no shading, 3D shading model in this tool. You just have plain PV modules which are oriented in a certain direction of the sky. And in the detailed losses, you see the only thing that you can define is the thermal coefficient of the PV modules and the losses in the cables, in the DC cables. To give you an example, let's say for this site, we choose a little less inclined panel at 10 degrees. I come back to my detailed losses and to my results. I can now have everything in green here on the left side. I can run my simulation. If I do this, it goes very quickly. It's hourly steps. This will not work in sub-hourly steps. And I have now my results, which are shown here. And I can have a report that resembles quite a lot the PVsyst report, the normal PVsyst report, with just less pages. Yeah, it's just a concise way of displaying the results. So this is basically functionality of this model. You can save your projects and then go over to the next one. Okay, and this is basically what PVsystBasic is doing. I'm coming back to my presentation. Again, as it's meant for regions and areas where the idea is to help people to have access to water and electricity. The license for this tool, which is separate from the PVsyst license, is sold at a symbolic price. And as you've seen, it's really meant for a very specific case of rural areas and small systems. And with this, I end my presentation of PVsystBasic. I have now with me Michele Oliosi, who will take over and say a little words on PVsyst CLI, the command line interface. Please, Michele.
Hi, Bruno, and thanks for the introduction. So PVsyst CLI is our third product we're presenting today. CLI stands for Command Line Interface, and it basically serves the purpose of running key PVsyst functions from the command line. The idea, and let me try to get the slides, is that PVsyst CLI will support the automation of your whole modeling process and try to speed it up. And so PVsyst without CLI itself is actually quite good when you're in that iterative phase of design, whenever you're changing electrical components or modifying your 3D scene, or maybe changing the granularity of the simulation. But once you have set up your workflow and you have to do multiple projects, all those UI and UI interactions can be quite tedious and time-consuming. And well, actually, we don't want you to miss your Christmas or any other celebration because you're running PVsys simulations and you have waiting for the next batch. So this is where PVsyst CLI comes in handy. It allows to set up an automatized workflow and try to remove those time-consuming actions in the UI. And so the idea is that you will then program it to perform the actions in your stead. So let the machine take over the whole running the simulations part. So we are presenting PVsyst CLI today also because there were some updates with PVsyst 8.1. So we also have the PVsyst CLI 8.1 update. The main functionality that was added was the possibility to create sites. So the SIT file is a very central part of a PVsyst project. And so previously, one could only work with weather and project data in CLI. So now it's actually possible to define a location and ask PVsyst CLI to create the SIT file. There is one necessary input, which is the monthly weather data. This means that this functionality will work best whenever you pair it with a weather database from which you can pull your weather data. And I'll show you some examples later, but I can already say that this opens up many possibilities. In terms of use cases, first you can, if you're doing some O&M, some monitoring, you can kind of automatize the production of your expected values for your production. And you can also try to search for new sites with prospection tools. Since we can create a new site, you can just plug yourself in a specific location and run a simulation at that place. And you can also use the batch mode since a few updates, which can help you with system optimization. So basically, these three different use cases are now available with CLI. So I want to show you some examples, and I was thinking of the prospection in particular. Nowadays, it's really easy to cook up many different interfaces and apps And I wanted to show you how to build an app out of PVsyst CLI. So here's the pipeline I wanted to use. The idea was fairly simple. As I explained before, you can take a weather database. The first step would be then to make an API call and gather some weather data, ideally monthly weather data. Then you can ask PVsyst CLI to do 2 steps. The first steps would be to create a site. And the second step would be to run a simulation with an existing project based on that site. And on that note, you don't need to import more weather data. There is an option within the run simulation to generate some synthetic hourly or sub-hourly weather data so that you can skip that step, basically. So I want to show that actually in practice. So let me just escape here. And so there you have it. And so basically this is works on the pipeline exactly as mentioned. So let's try to look up for a location. I'll try to aim for Geneva, roughly. And so you can add some information, but all of this is, let's say, fluff. Here, the idea is that you already have worked within PVsyst on your project. And so I have here a project that I worked on before called default project and some variants. And here I'm interested in a row-based system with a 10-degree tilt. So I will choose this one and simply click on Run Simulation. And so now my app is asking PVsyst CLI to create a site based on the weather data it fetched, and then run the simulation. So you can see now the step is running simulation. And so this has allowed me to do something that would have taken maybe 5 or 10 times more minutes within PVsyst. So now I have some valuable KPIs for that location. This is all programmable, of course. So, I mean, you could imagine anything you want with this tool. And there you have it. So going back to the slides we had before.
You have to get the focus on.
Yeah. Okay. So getting back here, our wish is that you let the robots cook up many different apps for you. And ideally that you try to be creative with all the whole possibilities that PVsyst CLI has. And actually, we're really looking forward to you coming up with many different use cases, and we will definitely help you set them up. So feel free to get in touch with us and ask us about your dreams with PVsyst. Now, let me just end with a small reminder. So if you want to get all the products we've shown today, so either PVsyst 8.1, PVsyst CLI, or even PVsystBasic, you can just go to our webpage, which is www.pvsyst.com. The installer for PVsyst and PVsyst CLI is the same. So once you press download, you will get basically both products, but you need separate licenses for them. So if you want to use PVsyst CLI beyond the trial that lasts 2 months, then you need to go to this website and purchase a different license than the PVsyst one. And there we have it.
Okay, thank you very much, Michele, for this nice presentation and for this example, which I think shows clearly the potential that you have with PVsyst CLI, yeah, and then what you can do with that. And we are looking forward to put more functionality into CLI and to see this develop, because we believe that the automation of workflow is important nowadays, especially in larger projects. And we are making efforts to get this accessible and then working also with the PVsyst simulation. And with this, we are basically closing the part of the presentation that we wanted to give. We come to our Q&A part. I remind you that there is a special tab in the webinar for creating, for asking your questions. We should now have already our team in the background who had has picked up your questions and we will get them here on the screen soon. Just hold on a second and we will try to answer them. Okay. Good. See if I got it. Okay. So the first question I see here is related to PVsyst 8.1, and it says, do we have an option to import SolarGIS data directly, not TMY data, but only data that we can import with SolarGIS Prospect? So I think this is a question to Oriane, who presented to us the weather data import wizard. So could you try to answer that question?
I'm sorry, could you repeat the question?
Do we have an option to import SolarGIS data directly, not TMY data, but only data that we can import with SolarGIS Prospect, the product?
So right now, I think we have 2 ways of importing SolarGIS data. There's the site. I think it's one of them available in the API.
Sure. Do you want me to answer the question?
Please, if you know
Well, I
better.
can try. I'm not sure I will answer, so correctly. But there are, 2 ways of, importing, SolarGIS data at the moment, through site, as you said. So you can import, so PMY, so it is, based on the web, API. And then, you can also, import it, via the known format. So you basically, download, the CSV file, from the SolarGIS, website, and then import it into PVsyst. So there's 2 ways of doing it.
And maybe I can add to this, as Oriane mentioned in her presentation. Right now, the known formats always generate hourly weather data files for PVsyst, but in the future, if you have a finer granulation of your time steps, we will also account for that.
And I can also add something that also the API calls themselves will be gradually expanded, because right now we're just generating the metronome data from the site creation, and the other features will also come along in the later batches.
Okay, the second question is about the sun position. How are the sunrise and sunset adjusted to the sub-hourly time interval? The sun doesn't rise or set at specific time intervals. So how is PVsyst dealing with accurate time adjustments? So I can answer to that. The sun position is indeed very important to get the right simulation. You have to have a representative sun direction for the simulation step you are performing. And in PVsyst, we place the sun in the center of our time interval. So if it's an hourly time interval, it will be half an hour from the borders. If it's a 1-minute interval, it will be 30 seconds from each border, but it's always centered on the time interval we are simulating. There are some special cases if the sun gets over the horizon line, where we only take the part where the sun is above the horizon. So then you are not exactly on the time step center, but slightly apart from that. But this is how we do this. And with this, we get really a sun position, which is representative for the time step we are simulating.
Should I ask question 3?
Yes.
Yeah. So the third question is the grid limitation calculated with sub-hourly timestamp if you're doing a sub-hourly simulation, or is this loss always only showing at inverter level? I think the question is more about whether the grid limitation also works simply with sub-hourly simulation.
Yes. So yes, indeed. I mean, the sub-hourly simulation really goes in sub-hourly steps. All the simulation stages that we do in hourly simulations, we do equally in sub-hourly steps. Now, the grid limitation in PVsyst up to now was limited to monthly values, but this has been changed already in version 8.1, the current version 8.1, where you can import a time series, and this time series can again go down to 1-minute time steps. So of course, then if you make a 5-minute simulation with 1-minute time series, we need to average over the 5 minutes. But in principle, You have the granularity of your simulation also for the grid limitation, and this is true not only for the grid limitation, but also for load profiles, for example, and soiling profiles that you can now import in sub-hourly steps, and PVsyst will match the best possible these time series to the simulation step that is being performed.
Mhm.
So maybe we have a question on PVsyst CLI now. Do you need a license for each user of CLI, or is only one CLI license on a Windows server required?
Well, the answer is that you just need one license on a Windows server. It's per installation. So the idea is also to try and run it on a different infrastructure that is not your personal PC or your work PC, but something with a bit more power and that could be shared.
Okay. And the second question is there a manual for PVsyst CLI? And is there a separate license required if there's already a license for PVsyst 8?
So separate licenses, as mentioned. So you need, two licenses if you want to work with both. And the manual, yes, there is also a help page, documentation on the web, just as the PVsyst documentation is on the web. You can find it rather easily. Let's show it directly. So, so here you have the support tab, and we get to PVsyst CLI help. And this is really looking like the PVsyst help. Both are connected. Here you can find all the information you need to start working with PVsyst CLI. I have to add that there are also some indications on how to add some example of scripts. So you can find all of this in the help. And I hope, if you have any more questions, of course, feel free to ask us directly.
Okay.
Yeah, let's go back to PVsyst. I think questions 4 and 5 go kind of together. The question is whether you can convert either monthly data or hourly data into sub-hourly data, and then run the simulation with PVsyst, of course. Maybe Oriane and Eric can answer this question.
Sure, we can.
Cool.
Obviously, well, we can try again. It is possible indeed, to convert, monthly data to, hourly, so sub-hourly, data, via, synthetic data tool, which is available in PVsyst. So this is based, on metronome data, just model, I believe.
But I might jump in and add that since we're talking about a stochastic process, if you generate two different files, one hourly, one sub-hourly, from the same monthly values, they don't necessarily match day per day. If you really want to have a direct comparison, you should generate a 1 minute data file, and then when you run the simulation, you should choose the hourly version to really have something matching your sub-hourly data.
So there is a question about timestamps, so we can continue with Oriane and Eric. So is the convention of sub-hourly data beginning of the interval for the timestamps?
Yes, so by default, that's the convention. So in PVsyst, when we say the time step is 12 hours, that refers to the beginning of a time step. So if you are in 5-minute data, your 12 hour is from 12:00 to 12:05. That's our convention. And then when you import data through the wizard, you can choose that. Like there's actually a setting, and you can choose if your actual CSV file has the same reference or if it uses a different reference, for example, the end of a time interval. And if nothing works, you can also like finely tune your import with a time shift.
Okay, thank you. There is another question concerning the sub-hourly simulation that says, did you study the impact of the uncertainty decrease? What percentage of improvement can we expect with a minute or 5-minute data compared to 1 hour? I mean, this is a very vague question because these sub-hourly steps have impact on many different parts. But I think the most important part will be the clipping. And maybe, Michele, you can give us a comment on how it changes the precision of the clipping corrections.
So indeed, if you use a hourly simulation without the clipping correction model that we were using in 8.0, then depending on the DC to AC ratio, you had different under evaluations of the clipping loss in the hourly simulation. If I recall correctly, that's under evaluation of the loss, so overestimate of the production, was around from 0 to 5%, depending on the DC to AC ratio. Now, with the sub-hourly simulation, that is cleared. However, I have to add that the main uncertainty of the simulation is usually not the models, but rather the weather variability, and that doesn't change much with the going to sub-hourly scale, and also the user input. I mean, there is just some parameters that you don't know very well, and you cannot be sure that they will be implemented as they are in the field. So that also is not really improved on. But regarding models, yeah, I would say at least the transposition, the clipping, temperature could be a couple percent gain in accuracy.
So thank you, Michele. We have a question on PVsystBasic, I see.
Right. Yes, so is PVsystBasic included in the standard PVsyst license or available separately?
It's a separate license indeed. Yeah, PVsystBasic is also a separate license, but as I mentioned, since it's aimed at situations where people have difficulty and access to water and electricity, we really made a very, very low price, which I would call symbolic. So it's not hard to get a PVsystBasic license as well. So maybe another question on the command line. Can we run PVsyst CLI with 1 day data only?
Yeah, that's no problem actually. So PVsyst CLI can be run with any weather data, so .met file that you create. So if your .met file has only 1 day, then the simulation will run for just 1 day. And so that's definitely possible. And yeah, I think this extends to any period within a year, basically. We don't have yet the possibility to run more than 1 year, but then you can run multiple simulations.
And then the next question is a little bit similar. Can we run the sub-hourly simulation with PVsyst CLI?
Yes, of course. So this was updated with a new option in the run simulation command, which is the time step of the simulation.
And the next question is, if I already have a large number of site and MET files, can I use CLI to run simulations of multiple variants on each of these sites? For example, I could create these variants beforehand using Python by processing a text file.
Yes, that is possible. Well, as I've shown, I just had some VC variants in the app I showed before, and then generated this SIT and MET on the fly. So even though you don't have SIT and MET files, you can do that. You can do it with existing SIT and MET files, of course. And I have to add on the idea of doing variants, you can also use a batch file. So either you can use your own scripts to modify the project as you want, but ideally you also want to use the batch file, which goes through PVsyst to modify those variants.
And next question, what is the purpose of weather data conversion with PVsyst CLI?
Good question, because I haven't used it in my app, but the idea is that if you have some actual weather data that you want to use for the simulation, you need a way to turn it into an MET file to then use in the simulation. So the weather data conversion serves that purpose to take that data and feed it to PVsyst.
Basically, it automatizes what Oriana showed you in
Yes.
her example. You have the MEF file, which describes the format, and you have a CSV file with your measured data or your weather data. And from these two together, you can create the MET file that can be used then in the simulations. And this you can do if you have the MEF file and the CSV data, you can do this then automatically with PVsyst CLI. And as a use case that comes to my mind would be, for example, you have a site that you are monitoring and regularly new data is coming in that you measure from your data loggers. You need to convert this data from the data loggers into MET files for the PVsyst simulations. And this could be fully automatic with PVsyst CLI, for example.
And is there a limitation on the number of simulations with PVsyst CLI per month? I don't think so, right? The license just allows you to run as many simulations you want, as long as your machine is capable of.
It can run on only one machine.
Yeah.
And PVsyst CLI commands are inbuilt, or we need to enter those commands every time when we wish to run this. Can we save the set of commands we use frequently?
Oh, that's a great question. So the way I personally use it and would recommend to use it is just to write a script that runs like a command line subprocess, and basically that generates those commands for you. However, it is possible if you have a complex chain of commands that you need to give, or a complex chain of options, to put that all into an options file and just give PVsyst CLI the options files directly. But I would say this is kind of an alternative to writing a script.
Okay, and I think with that, our time is also coming to an end. We've answered many questions. I see that you're interested, and it was interesting on what we were saying. I hope you took some interesting information home with you. I thank all the presenters, Oriane and Michele, were here with me to present this, but also all the team in the background who prepared and this webinar and helped with the technical aspects, and is now sitting right there reading your questions and moderating the chat. So it was a team effort, and I would like to thank all of them for that. Thank you for joining this, and I hope you will have success with your PV simulations, and hope that you enjoy working with PVsyst. Thank you very much, and have a nice day.
Thank you, Bruno, for your presenting.